Hey guys, how's it going? Mr. Mitchell here. In this video we're going to go over question 2 from the 2024 SQA Advanced Higher Physics exam paper. So let's get started. Question 2 says the motion of a battery-powered flying toy pig can be modelled as a conical pendulum. The pig has a mass of 0.230 kilograms and is attached to a ceiling with a thin string. The pig is set in motion and moves in a horizontal circle of radius 0.419 metres as shown in figure 2a. And we're told that the pig has an angular velocity of 3.01 radians per second. So there's our diagram of the toy pig on the end of the string, and we've got the angle theta to the vertical labelled, and the radius r of the circular motion that's traced out by the toy is also labelled. Part A says show that the tangential speed of the pig is 1.26 metres per second, and there's 2 marks available here. Well, writing down what we know from the question, we're trying to find the linear or tangential speed v. We're told that the angular velocity omega is 3.01 radians per second, and the radius r is 0.419 metres. So writing down our equation relating linear velocity, angular velocity and radius, we have v equals r omega. Substituting in the numbers gives 0.419 times 3.01, and putting that into your calculator should give you an answer of 1.26 metres per second. B part 1 says on figure 2b, show the forces acting on the pig as it travels at a constant speed in a horizontal circle. You must name these forces and show their directions, and there's 2 marks available here. Well, firstly, just like on any object, gravity acts downwards, so we can label the force due to gravity downwards, which is called the weight. And because of the string here, we're also going to have a force going back up the string called the tension, so we could label that here as the tension. So there's our 2 forces labelled for 2 marks. B part 2 says by considering the effect of the forces acting on the pig, show that tan theta is given by the relationship tan theta equals v squared over gr, where the symbols have their usual meaning, and there's 2 marks available here. Well, the best way to answer this is to think about the forces acting on the toy. So let's start by drawing this circle, which is the toy, and it's got a force downwards, which we said was the weight, so that we could label that as mg, and the toy pig is kept at a constant speed in the horizontal circle by the centripetal force acting on it, and that acts horizontally towards the centre of the circular motion traced out by the toy pig. So if the toy pig is at the left hand side of the circle, just like in the diagram, then the force will be acting towards the right in this case. And we could label that F to mean the centripetal force. And we can then say that since the vertical force is acting on the ball are balanced, then we can redraw this as mg going up the way. So we've got mg there, and the force F is still going to the right. And that's us saying that this upwards force mg is balancing this downwards force mg. And now what we can do is add the force vectors nose to tail. So if we draw our toy pig or our circle again, then we've still got our force F going to the right, but let's say we moved this vertical force now, the mg going up the way, to be nose to tail. So we're moving that tail for the mg vector along to join the nose of the centripetal force F vector. And now that we've got these vectors added nose to tail, we can draw the resultant force vector, which is going to go from the start to the finish point, so it's going to look like that, and we can add a double arrow onto it to show the direction it's going in. We can then label some angles, so we've got our right angle in there, and then we've got our angle theta up here, which is the same as the diagram we've got. Now remember, we want to show an expression for tan theta, so we could write here that tan theta equals opposite over adjacent, so opposite the angle theta we have F, and adjacent to the angle theta we have mg, so that's equal to F over mg, which is the same as mv squared over r over mg, where we're just expanding our expression for centripetal force here and writing it in terms of the linear speed. And then you'll notice that the m's on the top and bottom cancel out, and that leaves us with v squared over gr, which is what we wanted to show. B part 3 then says calculate the angle theta when the tangential speed is 1.26 metres per second, and there's 2 marks available here. Well, we just need to take the equation from the previous question and sub the numbers in. So we have tan theta equals v squared over gr is equal to 1.26 squared for the linear speed divided by 9.8 for the gravitational field strength on Earth times 0.419, which was the radius given in the question. And if you put that into your calculator, you should get 0.3866 and so on, but make sure you don't round your answer yet. To get theta, just take inverse tan or shift tan of that answer in your calculator, and you should get an answer of 21 degrees. Lastly, part C says the pig is battery powered to keep it moving in a horizontal circle. As the batteries run out, the tangential speed decreases. State the effect this has on the angle theta. You must justify your answer, and there's 2 marks available here. Well, we could say that since tangential speed decreases, the horizontal component of the tension which gives rise to the centripetal force must decrease, and the weight stays the same. Therefore, the angle theta decreases. So you get a mark here for stating that the angle theta decreases, that's your conclusion, and you get a mark here for the justification, but make sure you mention this last part that weight stays the same as well in order to get the second mark. That's all for this video, folks. Thanks for watching. If you made it to the end, I really appreciate it. Make sure to give the video a thumbs up, subscribe to the channel, and I'll see you in the next one. Take care.